Hello and welcome back to the channel Science Math and Engineering. Today we are going to solve the GATE 2012 Mechanical Engineering paper part 2. So let's get started. Here we have 15 questions from 26 to 40. So let's start with question number 26. These are all 2 marks questions. The homogeneous state of stress for a metal part undergoing plastic deformation is, so our T is given. So this is the state of stress where the shear stress component values are in megapascal. Using von Mises yield criterion, the value of the estimated shear yield stress in megapascal is, so we need to find out the von Mises yield criterion. Okay, so the answer is B. So let us see how we get it. So sigma x here it is 10 megapascal, sigma y is 20 megapascal, and sigma z is minus 10 megapascal. Tau xy is 5 megapascal, tau yz is 0, and tau xz is again 0. So we know sigma e is half of sigma x minus sigma y whole square plus sigma y minus sigma z whole square plus sigma z minus sigma x whole square plus 6 tau square xy plus 6 tau square yz, or plus 6 tau square zx. Here 6 is missing, so it is 6. So from here we get sigma e is root over 0.5 into sigma x, that is 10 minus 20, so it is minus 10 square, so 100. Then sigma y minus sigma z, so 20 minus minus 10, so plus 30, whole square is 900. And then sigma z minus sigma, so minus 10 minus 10, so minus 20 whole square, it is 400 plus 6 into tau xy whole square, so tau xy is 5, so 6 into 5 square. So we get from here sigma e is equal to 27.8388 megapascal. Now tau y is how much? Sigma e divided by root over 3. So this is equal to then 16.073 megapascal. Okay. So we'll go to the next question. Details pertaining to an orthogonal metal cutting process are given below. So chip cutting, chip thickness ratio is given, that is small r is given 0.4. Undeformed thickness is given, rake angle is given, cutting speed is given, mean thickness of primary shear zone is given. So we need to find out the shear strain rate. Okay, so the answer is R is given 0.4, T1 is given 0.6 mm, then rake angle alpha, so these are given. So as we know 10 pi is equal to r cos alpha divided by 1 minus r sin alpha. So we get 10 phi is 0.4233. So that means phi is equal to 22.944 degree. Now again Vs is V cos alpha by cos of phi minus alpha. So from here we get Vs is equal to 2.5262 meter per second. So now shear strain rate would be equal to Vs divided by Tm. So Tm is already given here 25 micron. So Vs divided by 25 micron, so it comes to a shear strain rate as 1.01048 into 10 to the power 5. Okay, so the option C is the correct answer. So we'll go to the next question. In a single pass drilling operation, a throw hole of 15 mm diameter is to be drilled in a steel plate of 50 mm thickness. Drill spindle speed is 500 rpm, feed is 0.2 mm per revolution, and drill point angle is 118 degree. Now assuming 2 mm clearance at approach and exit, the drill time in seconds we need to determine. So the answer is, so it is 35.1 seconds. So see how we can get it. The length of the hole is the thickness of the plate, that is 50 mm, right? Then half point angle alpha is 118 degree by 2, so it is 59 degree. Now breakthrough distance, that means how much we need to break through this thickness, that is extra amount that we need to, that the drill need to means go through that hole, that is equal to d divided by 2 into 10 alpha. So it is comes as 4.5 mm. So total length of the tool travel. So total length of the tool that it will be traveling is this length of the hole, plus this breakthrough distance, plus this 2 mm clearances that we were asked at approach and exit. Okay, so that also we need to consider. So from here we get the total length of the tool travel is 58.5 mm. Now machining time would be equal to L divided by F into N, where F is the feet per revolution. So in one revolution it gives 0.2 mm. So in 500 revolutions it will give how much? 500 revolutions it gives 100 100 revolutions, right? In 100 mm, 100 mm it gives, but in 1 minute. So we total need 58.5 mm. So 58.5 divided by F into N, so it comes as 0.585 minute, which is equal to 35.1 second. Okay, so we'll go to the next question. Consider two infinitely long thin concentric tubes of circular cross section as shown in the figure. If D1 and D2 are the diameters of the inner and outer tubes respectively, then the view factor F22 is given by, so this is a heat transfer problem. So the answer is, see, for any convex surface Fii is equal to 0. So F11 is 0. Now from our reciprocity relation, Ai into Fij is equal to Aj into Fji. So A1 into F12 is equal to A2 into F21. And then we have the summation rule, which says that f of 11 plus f of 12 is equal to 1, and f of 21 plus f of 22 is also equal to 1. Now as f of 11 plus f of 12 is equal to 1, so we get f of 12 is equal to 1 as f of 11 is equal to 0. Next, a1 into f12 is equal to a2 into f21. So from here we get f21 is equal to a1 by a2 into f of 12. So pi into d1 by pi into d2, and length is L. So into f of 12 is again 1. So we get d1 by d2. Now f of 22 is equal to how much? 1 minus f of 21. So it is equal to 1 minus d1 by d2. So our option D is the correct answer. We'll go to the next question. An incompressible fluid flows over a flat plate with zero pressure gradient. The boundary layer thickness is 1 millimeter at a location where the Reynolds number is 1000. If the velocity of the fluid alone is increased by a factor of 4, then the boundary layer thickness at the same location in millimeter will be. So we need to find out the boundary layer thickness at the location. So the answer is C. See, from Blasius's equation we know delta by x is approximately equal to 5 by Rex to the power half. Now as location is same, so x is constant, so delta is directly proportional to 1 by Rex to the power half. So again Rex is what? Vd by nu. Now we know this is our fluid is constant, our diameter is constant, and our nu is constant. And fluid is constant, so nu is constant, diameter is already constant, it is given. So we have Rex is directly proportional to only the velocity v. Therefore delta is inversely proportional to square root of v. So delta 2 by delta 1 would be equal to root over v1 by v2, which is equal to how much? V2 is 4 times of v1, so v1 by v2 is 1 by 4, so root over v1 by v2 is 1 by 2, that is 0.5. So delta 2 would be 0.5 mm as delta 1 is 1 millimeter. Okay, so we'll go to the next question. A room contains 35 kg of dry air and 0.5 kg of water vapor. The total pressure and temperature of air in the room are 100 kilopascal and 25 degree respectively, 25 degrees centigrade respectively. Given that the saturation pressure for water at 25 degrees centigrade is 3.17 kilopascal, the relative humidity of the air in the room is, so you need to find out the relative humidity. Okay, so the answer is, see, specific humidity would be mv by ma, where mv is the mass of water vapor in the given volume and ma is the mass of dry air. So it is already given as 0.5 is the mass of dry air, sorry 35 is the mass of dry air and 0.5 is the mass of water vapor. So you have omega is equal to 1 by 70. Now omega is equal to 0.622 into PV by PT minus PV. Here the total pressure would be the atmospheric pressure, and which is equal to 100 kilopascal. It is already given that the total pressure of air is the 100 kilopascal. Okay, so 1 by 70 is equal to 0.622 into PV by 100 minus PV. So from here we get PV is equal to 2.245. Okay. Next, relative humidity phi is PV divided by PVS. Now PV is 2.245 and PVS is given as 3.17. So our relative humidity is 0.708201, and in percentage terms it is 70.82%, which is approximately equal to 71%. So we'll go to the next question. A fillet welded joint is subjected to transverse loading F as shown in the figure. Both legs of the fillet are of 10 mm size and the weld size is 30 mm. If the allowable shear stress of the weld is 94 megapascal, considering the minimum throat area of the weld, the maximum allowable transverse force in kilonewton is, okay. So this is a fillet welded joint. So let us see the answer. See, the legs of the fillet, that is h is equal to 10 mm, that is 0.01 meter. Okay. Weld length is twice L equal to 30 millimeter, that is 0.03 meter. Now allowable shear stress of the weld sigma T is 94 megapascal. So maximum allowable transverse load is 2 into 0.707 into H into L into sigma T. So from here we get P is approximately equal to 19.93 kilo Newton. Okay. So I'll go to the next question. A concentrated mass M is attached at the center of a rod of length twice L as shown in the figure. The rod is kept in an horizontal equilibrium position by a spring of stiffness K. For very small magnitude of vibration, neglecting the weights of the rod and the spring, the undamped natural frequency of the system is, so you need to find out the natural frequency of the system. See, so the answer here, see, as this we have a weight here, so it will have a small displacement. So let us see how we can find out this natural frequency. Seeing that this mass is concentrated at this point, okay, M. Now we have a displacement x here and we may have a displacement delta here. This length is L, right? Now taking this moment about the point A, this is, let this point be A at the hinge. So Kx is the force applied here. So Kx into A, for Kx into twice L, this L twice L, Kx into twice L is equal to mg into L. So implies x equal to mg by 2k. Okay. Now from similarity of triangle we get delta by x is equal to L by 2L. So it is half. So delta would be equal to mg by 4k. Now using static deflection of the mass m, we have omega n would be equal to root over z by delta, which is equal to root over 4k by m. So our natural frequency in radian per second is root over 4k by m. If we need in hertz, then it will be 1 by 2 pi root 4k by m. So we'll go to the next question. The state of stress at a point under plane stress condition is sigma xx is 40 megapascal, sigma yy is 100 megapascal, tau xy is 40 megapascal. The radius of the Morse circle representing the given state of stress in megapascal is, so we need to find out the radius of the Morse circle. Now the formula for that is, see, the radius of the Morse circle is also the maximum shear stress tau max. So tau max would be equal to, tau max is equal to root over tau xy whole square plus sigma xx minus sigma yy by 2 whole square. So we get tau max is equal to 40 square plus 40 minus 100 is 60 by 2 is 30. So 30 square. So root over 40 square plus 30 square, which is equal to 50 megapascal. Okay. So we'll go to the next question. The inverse Laplace transform of the function fs equal to 1 by s into bracket s plus 1 is given by, so we need to find out the Laplace inverse. So the answer is, see, whenever we have a Laplace inverse and we have one this kind of an equation, we need to break it down into its individual fraction with some arithmetic plus or minus basically. So this Laplace inverse is equal to then 1 by s minus 1 by s plus 1. So now Laplace inverse of 1 by s minus Laplace inverse of 1 by s plus 1. Now Laplace inverse of 1 by s is 1 and Laplace inverse of 1 by s plus 1 is how much? It is e to the power minus t. So we get Laplace inverse of this whole fraction 1 by s into s plus 1 is equal to 1 minus e to the power minus t. So these are the identities that we are using. Okay. So we'll go to the next question. For the matrix A equal to 5, 3, 1, 3, one of the normalized eigenvectors is given as, okay, so you need to find out the normalized eigenvector. So the answer is, see, A is given 5, 3, 1, 3. Now the characteristic equation is A minus lambda I equal to 0. So modulus of height minus lambda in 3, then 1, and 3 minus lambda is equal to 0, which implies 15 minus 8 lambda plus lambda square minus 3 equal to 0 implies lambda square minus 8 lambda plus 12 equal to 0. That means lambda is equal to 2 or 6. Okay. Now A minus lambda I into x equal to 0. So if you put here, we get this with this matrix. Then for lambda equal to 2, we get it is 3, 3, then 1, 1. So which gives the gives one independent equation 3x plus 3y equal to 0. That means what? X by 1 equal to y by minus 1. So our eigenvector is 1 by root 1 and minus 1. Now if we multiply any number, that will also be a required eigenvector. So 1 by root 2 and minus 1 by root 2 is one of the eigenvectors. Now see, if we put lambda equal to 6, then we get minus 1, 3, 1, minus 3. So again it will be 1, 3 and it will be minus 1 and 3. So it is like minus 3, minus x plus 3y equal to 0. So that would again become as x by 3 equal to y by 1. But if we see here, 3 by root 10 is there, but it is minus 1 by root 10. Had this been 1 by root 10, then this would also have been a normalized eigenvector of this matrix. Okay. So here only one option is correct, that is option B. So we'll go to the next question. Calculate the punch size in mm for a circular blanking operation for which details are given. So we have the size of the blank, we have the thickness of the sheet, we have the radial clearance between punch and die, and we have the die allowance. Okay. So the punch size is how much? The diameter of the punch would be diameter of the blank minus 2 times the radial clearance and minus the die allowance. So we have diameter punch would be equal to 25 minus 2 times the radial clearance, because both sides we need clearance. Okay, so it will be 2 into 0.06 minus the die allowance is minus 0.05, so it comes as 24.83 millimeter. Okay, so we'll go to the next question. In a single pass rolling process using 410 mm diameter steel rollers, a strip of width 140 mm and thickness 8 mm undergoes 10% reduction of thickness. The angle of bite in radian is, okay, we need to find out, this is a rolling process operation and we need to find out the angle of bite. Our reduction in thickness is also given. So we have small d is given 210 mm, so small r would be, that is radius of the roller would be 205 mm. Thickness of the strip T1 is 8 mm and delta is 10% of T1, that is 0.8 mm. Now angle of bite in radian, if you need to find, it is theta is equal to cos inverse 1 minus delta by 2r. So it is equal to cos inverse 0.998 and in radian it is 0.0624a, which is approximately equal to 0.062, okay, in radian. Okay, we'll go to the next question. In a DC arc welding operation, the voltage arc length characteristic was obtained as V arc equal to 20 plus 5L, where the arc length L was varied between 5 mm and 7 mm. Here VR denotes the arc voltage in volts. The arc current was varied from 400 ampere to 500 ampere. Assuming linear power characteristic, the open circuit voltage and closed short circuit current of for the welding operation are. So we need to find out the open circuit voltage and the short circuit current. See, we have V arc is 20 plus 5 into L. Now our power source characteristic is linear, so we can assume that V arc is A plus Bi. As the length increases, current decreases. So for L equal to 5, I is 500 ampere. So from here we get V arc is 45 volt then, and for L equal to 7, I would be 400 ampere. So as length increases, current decreases. So from here we get V arc is 55 volt. So from these two equations we get A is 95. Okay. Now V of arc and B is minus 1 by 10. So we get V of arc is how much? 95 minus 0.1 I. Now V arc is open circuit voltage when I is 0. So when I is 0, this becomes 95. So open circuit voltage is 95 volt. And when V arc is 0, there is no voltage, then the I is short circuit. Okay. Means when you get short circuit current, then voltage is, there is no longer any voltage. So we get 0 is equal to 95 minus 0.12 I short circuit current. So short circuit current is 950 ampere. Now this can also be done using this method. You see, V arc is 520 plus 5L. As length increases, current decreases. So that is same. Now the power source characteristic is linear. So V by V of open circuit voltage plus I by I of short circuit current is equal to 1. Okay, we can use this relation directly. So here you get 45 by V open circuit voltage plus 500 by I short circuit current is equal to 1, and 55 by V open circuit voltage plus 400 by I short circuit current is equal to 1. So from these two equations we again get that V of open circuit voltage is 95 volt and I, that is the short circuit current, is 950 ampere. Okay, so we'll go to the next question. A large tank with a nozzle attached contains three immiscible inviscid fluids as shown. Assuming that the changes in H1, H2 and H3 are negligible, the instantaneous discharge velocity is, see, we need to find out the discharge velocity. Okay, so the answer is, the pressure at this point A is how much? P, the pressure would be atmospheric pressure plus rho 1 into G into H1. This is exerting rho 1 into Z into H1 at this interface. Now this liquid will be exerting rho 2 into H2 into Z plus this whole one, and when we come here, then the upper two pressure plus the pressure exerted by his, that is rho 3 into H3 into Z. Okay, so from here again, now PB would be what? Atmospheric. These two have no jet difference, no height difference. Okay, again velocity at this point is 0, and velocity at B we need to determine. Now pressure we already know, so using Bernoulli's theorem we get PA by, only this liquid is here, right? So PA by rho 3Z plus VA square by 2Z plus ZA is equal to PB by rho 3Z plus VB square by 2Z plus ZB. These are equivalent. Okay, we are assuming no losses. So from here, PA by rho 3 is equal to PB by rho 3 plus PB square by 2. We are cancelling all G's, and ZA, ZB cancelled, and VA is 0, so this term cancelled. So only first term here of here remains, second term of this, uh, first term of this, and second term of the right hand side. So from here we get VB would be equal to 2 into PA minus PB divided by rho 3. Now PA minus PB is how much? Rho 1 H1Z plus rho 2 H2G plus rho 3 H3Z. Okay. So from here we get VB is equal to 2 into Z into H3, rho 1 H1 divided by rho 3 H3 plus rho 2 H2 divided by rho 3 H3 plus 1. Okay. So with this we conclude the part 2 of the GATE Mechanical Engineering 2012 paper. This is the part 2 of the paper. So we will come up with the part 3 shortly. So thank you for watching. See you in the next one.